Welcome viewers. In this video we'll see the direct and quadrature axis synchronous reactance of a alternator, that is for alternator. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, direct and quadrature axis synchronous reactance. We are going to find the reactance of direct and quadrature axis. The flux pi AR has two components, pi d and pi q. This d axis and q axis separate video available. In that the explanation is given. So in general, flux equal to mmf by reluctance, or it can be written as 1 divided by reluctance into mmf. This 1 divided by reluctance is nothing but permeance. Reluctance means opposing parameter, permeance means permitting parameter p. So 1 divided by reluctance can be written as permeance. So flux equal to permeance into mmf, that is p into f. We'll take p into f. So pi equal to permeance into mmf. But we have two axes, q and d and q axis. So pi d equal to pd into fd. Pi q equal to pq into fq. So now we have two components, flux in the direct axis and flux in the quadrature axis, pi d and pi q. So mmf equal to f equal to number of turns into current. General formula is number ni, n into I, or armature reaction coefficient into current. Here we consider the armature reaction. So based on that, fd equal to kar into id. This is a constant, armature reaction constant for d axis. Similarly, fq equal to kar into iq. So finally we can write pi d equal to pd into fd. Fd we can replace this kar into id. Similarly, pi q equal to pq into fq. Fq can be replaced by this value, kar into iq. So finally we got the expression for pi d and pi q in terms of armature reaction coefficient, current and permeance. Pi d produces mmf ed, which lags pi d by angle 90 degree. So ed can be written as ke pi d into k of angle minus 90 degree, because lagging. So lagging minus 90 degree can be represented by minus j. So minus j ke pi d. Similarly, pi q produces emf eq, which lags pi q by an angle 90 degree. So this is also lagging. So eq equal to ke pi q of angle minus 90 degree. That can be represented as minus j ke into pi q. So we got the expression for ed and eq. Ff produces a flux pi f, which gives an emf E phase. Therefore the resultant emf is given as ER, resultant emf equal to E phase plus ED plus EQ. So that ER, the resultant emf equal to E phase, this ED is nothing but minus j ke pi d. Similarly, EQ equal to minus j ku pi q. Just now we discussed. So that is based on this. This pi d and pi q can be replaced by this expression. So that resultant emf equal to E phase minus j ke. Pi d is nothing but pd kar id is replaced. Similarly, this pi q is replaced by pq kar iq. So this is the resultant mmf. Now we'll see this. So let ke pd kar is written as xard. That is a component of armature reactance along d axis. X refer reactance, AR refers armature reactance, this D refers the direct axis. Similarly, KE, PQ, KR is XARQ, the reactance in the Q axis of armature reaction, reactance in Q axis. So that the above equation can be replaced as resultant MMF equal to E phase minus XARID. So this term is written as XARID. Similarly, minus J XARQID. I will take this equation number 1. So we got the first equation, resultant EMF. For an alternator, the EMF equation is, general equation is resultant EMF equal to V phase plus IARA plus IAXL. Armature reactance drop, then armature inductance drop. But IA equal to ID plus IQ. We are using this two axis. So we have to replace resultant EMF equal to V phase plus IARA plus J. This IA is written as ID plus IQ into XL. Now multiply inside. The resultant EMF equal to V phase plus IARA plus J IDXL plus J IQXL. You take equation number 2. So already we got the resultant EMF equation 1. This is general. Based on the general concept of alternator, we got resultant EMF equation 2. So both are same. Equation 1 and 2 is the nothing but resultant EMF. So we can equate on both sides. Right hand side is equal, so that we can equate the parameter of left hand side. So E phase minus JXARID minus JXARQID equal to V phase plus IARA plus JIDXL plus JIQXL. Right. Now V phase. Now we will brought these all these two terms the right hand side. So this negative become positive. So these two terms are brought this side. Then this ID is commonly available here as well as in this term. Third term and fifth term. So this is taken commonly. Similarly, IQ available in fourth and sixth term, that is taken commonly. So in that this XL plus XARD is written as XD. D axis synchronous reactance. XL plus XQ XARQ is written as XQ. Q axis synchronous reactance. So we can write this is the XD and this term is XQ. So that E phase equal to V phase plus IARA plus JIDXD plus JIQXQ. So this is the final equation we got. Now we'll see the phasor diagram. Based on that, how we are represented in phasor diagram. So this equation can be represented in phasor diagram as follows. Now we refer the phasor diagram. So this is the resultant EMF E phase that we need to find. That is the final aim. So that is lagging this with E phase. E phase, this is V phase. V phase lagging E phase by an angle of delta. So we draw the line V phase. This is IARA drop and IDXT drop and IQXQ drop, that is perpendicular. These are all in phase. That this is a normal axis. This is quadrature axis. So what the equation we saw, the resultant EMF E phase equal to V phase plus IARA plus IDXT plus IQXQ. So the vector sum of V phase, IARA, IDXT and IQXQ, that will give the resultant EMF E phase. Now we'll go to the remaining part of the phasor diagram. So now consider this IA, current IA, that is lagging E phase by angle pi d. So this is the IARA drop, that is resolved. This IA is the vector sum of ID and IQ. IQ in quadrature axis, ID in normal axis. Then we'll see the drop, IARA drop. This IARA drop resolved into two components. IQRA, that is BE. The BE value is IQRA. This AE value is IDRA. Vector sum of these two is IARA. From B, draw the vertical line that will give the point G. From E, draw the vertical line that will give point F, that is IQRA. That will give the resultant value IQRA. So this FG is equal to EB, both are same. Both are IQRA. So now we extend the IA line. This dotted lines, this IA line is extended, and this line is drawn where it meets this resultant EMF, this I. From there you draw the perpendicular line that will give K. So through the point B we have drawn this line. So the vector IA is extended through the B. This HI line is drawn. This I is perpendicular line is drawn. Where it meets this line is K. So from this triangle BIK with an angle of theta, we are able to find the value of BI. The calculation is available. At that time we will see how we are calculating, right? So the first we discuss the total EMF. Next we discuss this IA. Third we are discussing this extending the line so that we are getting this triangle BIK. From that we calculated the, with using angle theta, we are able to find the value of BI. So in the fourth step, consider the triangle OHI with an angle theta. Using this triangle we are able to find the value of HB. This value is calculated using this triangle. Now consider the another triangle OAJ. This is OA, then J, this triangle, this small triangle with an angle pi. From that we are able to find the BI. This BI is already calculated. Here we can calculate OH. This OH value is calculated using this triangle OAJ. So from that finally we can find the theta value. This theta value is calculated. From the theta value we are able to find the E phase, resultant EMF. Once the resultant EMF is calculated, we are able to find the voltage regulation. So I will explain again. The first step we consider this line V phase, IARA, IDXT, IQXQ. We calculated E phase from the equation. Then we consider IA, that is vector sum of ID and IQ. Then this IARA resolved into two components. That is, lines are extended, both are same. FG is equal to EB. Then we consider this IA is extended. IA line is extended through the B. The line is drawn, that is I. Then vertical line is drawn, that is K. So that we are able to find the BI value. Next we consider the triangle OHI. From that we calculated HB, this value. Then we consider the triangle OAJ, this small triangle. From that we calculated JH, this value. Finally, from this triangle, by using this value we are able to find the theta. Further we are able to find the E phase. That we'll see the calculation. During calculation all these are available, all this explanation. From the resultant E phase we are able to find the regulation. Now we'll see the detailed procedure how to draw this phasor diagram. Draw the V phase vector OA. For lagging load, IA lags VP by an angle pi. So what we discussed earlier, the description is available, procedure is available. IA has two components, ID and IQ. IARA drop is in phase with IA, that is AB equal to IARA. IDXQ is at 90 degree to ID, that is BC equal to IDXD. IQ x cube is at 90 degree to IQ. That is CD equal to IQ x cube. So from this, E phase equal to V phase plus IARA plus IDXD plus IQ x cube. From the diagram, E phase is the vector sum of these components. So therefore join OD to get the E phase, that is OD equal to E phase. Angle between E phase and V phase is delta. Angle between E phase and IA is theta. From phasor diagram, IA has two components, ID and IQ. ID equal to IA sin theta, IQ equal to IA cos theta. From that, we can write cos theta equal to IQ by IA. We will take this equation number 3. Already we have equation 1 and 2. The IARA drop represented by AB can be resolved into two components, IDRA, IQRA. That is AE equal to IERA, IDRA, EB equal to IQRA. From A, drop a perpendicular to OD to meet at point F. From B, drop a perpendicular to OD to meet at point G. So from A, we are getting point F. From B, we are getting point G. So that FG equal to EB equal to IQRA. So equation number 4. Now extend the current vector IA. Draw a perpendicular HBI to the vector IA. From I, drop a perpendicular to BC to meet at K. So in triangle BIK, the angle BIK is theta. We already discussed in the diagram. So that cos theta equal to IQ divided by BI. IQ is nothing but IK is nothing but IQ into XQ divided by BI. We know that IK equal to CD equal to IQ XQ. So that BI equal to, from this diagram we can write BI equal to IQ XQ divided by cos theta, because cos theta equal to IQ by IA. So that we can substitute that. This cos theta is replaced by IQ by IA. This IA, IQ got cancelled. This IA will go to the numerator. So IA XQ by IQ into IA. That is equal to IA XQ. Right? This IQ got cancelled. Only we have IA into XQ. So that BI equal to IA XQ. Equation number 5. Right? So in right angle triangle OHI, tan theta equal to HI by OH. That is HI equal to HB plus BI splitted. We know that HB is equal to AJ. In triangle OAJ, AJ equal to V phi, V phase sin theta, OJ equal to V phase cos pi. Sorry, V phase sin pi, V phase cos pi. So HB equal to AJ equal to, we can write V phase sin pi. This AJ is nothing but V phase sin pi. BI equal to IA XQ. So OH can be written as OH, OJ plus JH. This JH is nothing but AB, that is equal to IA RA. Now we'll find, finally we are going to find the tan theta from the triangle OAJ. HI divided by OH. HI is nothing but HB plus BI. OH is nothing but OJ plus JH. So all these values are available. Right? HB available, this HB is available here, BI available, right? OJ and JH is nothing but OH. This JH is available. All the values are available. Then OJ also available. Now we'll substitute all these values. HB is V phase sin pi, BI is IA XQ, OJ is V phase cos pi, JH is IA RA. Now we'll find the theta. Theta equal to tan inverse of this parameter, this term. So in general formula, theta equal to V phase sin pi plus or minus. We are adding this plus or minus Ia x cube divided by V phase cos pi plus or minus Ia Ra. Plus indicates lagging power factor, minus indicates leading power factor. This theta is nothing but pi plus or minus delta. For lagging, theta equal to pi plus delta. So that delta equal to theta minus pi. For leading, theta equal to pi minus delta. So delta equal to pi minus theta. Right? Here theta minus pi, here pi minus theta. Now from the phasor diagram. Now we are checking with the phasor diagram. E phase equal to OD. That is the first thing we calculated. That is written as OF plus FG plus GD. So from triangle OAF we know that OF equal to V phase cos pi. GD equal to BC equal to ID XD. FG equal to IQ RA. OF equal to V phase cos pi. So all the values are available. We can substitute. E phase equal to OF. OF is V phase cos pi. FG is IA IQ RA. Then GD is ID XD. Right? All the values are substituted. This is the final parameter we calculated from the phasor diagram. Then general formula. What is the general formula? E phase equal to V phase cos pi plus or minus IQ RA plus or minus ID XD. Plus indicates lagging power factor, minus indicates leading power factor. So once we know this E phase, we can be able to find the regulation of the alternator using this formula. Percentage regulation equal to E phase minus V phase divided by V phase into 100. So finally we calculated the regulation. So in this video we discussed the direct and quadrature axis synchronous reactance of a alternator. Using the phasor diagram, finally we got the E phase value. From that we are able to find the percentage regulation. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.